Today we will learn some useful functions, find out how to create dependencies, and of course how to create animation without any keyframes. We also will give you some useful written expressions that will probably come in handy in your working process. So let's start. Well, each layer on a timeline has its own specific number, which you can find here in this column. And this number can be used in many ways in your expressions. To refer to this number using expression, just type index. For example, we have such text layer, and I will type index in expression field of source text parameter. Now text shows us 1, as layer index is 1, but if I duplicate it, and the layer with second index will show us 2. Third will show us 3, and so on. So how can we use it? Actually, there are a lot of different situations that can't be solved without this number. For example, in cases we need to loop through all of the layers, or create automatic layer shifting, and many other things. Let's create a simple repeater for layers. For example, I have such rectangle, and I want its copies to be automatically placed in a circle around the center of composition. First of all, place the anchor point to the center, and for rotation property type the following expression. Well, for example, I want each next layer to be rotated by 60 degrees. Type 60, multiplied by open parentheses, and index minus 1. We have subtracted the 1 because we don't need the first layer to be rotated. 1 minus 1 is 0, and that will create for us a 0 rotation. Well, now duplicate the layer, and everything works fine. Each next copy is rotated by 60 degrees. But what if I don't know how much copies I want to create? But I want these copies to be automatically distributed in a circle. For that we need to calculate the rotation angle at first. And that's pretty easy to determine. All we have to do is 360 degrees divided by numbers of layers. So let's create a variable for angle and write and type 360 divided by this comb period num layers. Num layers is a composition variable which stores the amount of its layers. And now we need to multiply index by this variable, not by 60 degrees. Duplicate the layer and everything works fine like in repeater. But we have a lot of advantages as we can edit each copy separately. For example, change its color or rotation or any other property. And that's pretty cool, because that was not possible to do in repeater. Let's repaint the rectangles. For example, each even rectangle will have another fill color. Just delete all of the copies for now. Open shape, rectangle properties, find fill, and write an expression for color parameter. If index modulus 2 equals 0, that means if the remainder of divided by 2 equals 0, the layer is even and we will paint it in different color. So let's add a color control to this layer and set the color for even layers and pigwhip it to expression. Then write else, that means if the layer is uneven. For this case, let's leave initial color and type value. Duplicate the layer. But what if we want rectangles not to look at the center? We want them to be placed in a circle, like carousel. That's not as complicated as it seems at first look. Each layer has its own rotation property, and each rectangle inside it has its own transformation properties as well. So we need to work with rectangle rotation property. Rectangle must be rotated on the same value as layer, but in opposite direction. So just go to rectangle rotation, and here with the pigwhip tool, just take the value from layers rotation and make it negative. Now duplicate the layers. Cool, it works like it should. Well, in general there could be any other illustration instead of simple rectangles, and that's not all examples of index usage. You can do with it many things, like it was said before. And let's move further. The next very useful function is value at time, which allows you to get the value of any property from specific moment of time. We have this rotating rectangle in the composition and the text. Let's parent the source text parameter to rotation property of rectangle. And now, the rotation values on each frame are shown on the text layer. But if I go to expression and add period after rotation, type value at time, open parentheses, and here in parentheses we have to pass the time value expressed in seconds from which we want to get the value. For example, I'll type 1. Now, there is only displayed 180 because it is the value of rectangle rotation that it has at a time of 1 second. And if I move the keyframes, the value is changed, and it works correctly. It is still the value from 1 second. Cool. Let's create more complicated example. Something like repeater but with time offset. So we have such animation on rotation property of this circle. Well, I want the copies of this layer to move with time offset automatically. I don't want to move them on a timeline manually. Duplicate the layer one time. This copy is temporary. And open expression field on rotation property. Let's think of logic of what we're gonna be doing now. It's obvious that if there is only one layer on the timeline, it don't need to be shifted. But copies should be shifted in time relatively to the main layer and to each other. To make layer know about if he is a copy or original, let's write a simple condition. If index is greater than 1, open curly brackets, and pick whip the rotation property from copy. Look at this property link. Now we refer to the layer by its name, but it is also possible to do this by its index. So delete the name and type index -1 to make the layer take the value from the property of previous layer. And to create the time offset, type value at time, and in parentheses type time. That means that we take the value from current time and minus really small value, for example 0.05. That's going to be our offset. And of course, don't forget to write else condition, which will determine what to do if index equals 1. In that case, we need to leave the initial value. So just type value. Duplicate the layers. And it works pretty nice. Now let's make each copy be smaller from previous one. Once again, delete all the copies for now. Go inside Contents of Shape layer, select the ellipse and open Scale property in its Transform tab. Let's create expression. Once again, only copies will be smaller, so write the condition. If index is greater than 1, we are going to do something and else value. For first condition, pick with the current property. Now the length of property is pretty short. As you can see, there is no reference to comp and layer, because we pick-whipped the property of current layer. Let's make the link more generalized and write this comp. That means that we are going to find the layer in this comp. And by the way, don't be surprised, because we also can pick-whip properties from different comps. Then refer to the layer using index, layer index -1, to make the property depend from the same property of previous layer. Don't forget to put the period. Let each next copy be by 20% smaller from previous. So for that, just multiply the current value by 0.8. Duplicate the layers, and that works like it should. Pretty cool. And the next function which we need to get familiar with is linear. Linear allows you to create the linear dependency of any two parameters. For example, these two sliders. One is changing its value in range from 0 to 89, and the second from 0 to 32. Using linear, we create a dependency of a small slider from greater one. That means when I move the greater slider from 0 to 89, the smaller one moves with the same proportion, but in range from 0 to 32. The linear function has the following syntax. In parentheses, we need to pass 5 parameters. T, its input variable, the one which the current value will depend from. Tmin and Tmax, its input minimum and maximum. And value 1 and value 2 are minimum and maximum of current value. For example, we have two squares. One has animation of scale property from 0 to 100, but with bounds, and I want the second square rotation property depend from scale of first. Open the expression field on rotation property, create a new variable, and pick-whip the scale property of the first layer. but type 0 in square brackets in case to take only one parameter, because rotation property has only one parameter, and we don't want to write any arrays in linear function besides it's also possible. Then type linear s means our scale, when it is changing from 0 to 120. 120 is to include the bounce animation. We want the rotation to change from 0 to 180. And play the animation. This is a nice example of linear dependency of absolutely different properties. Linear function can be also used to create the animation without any keyframes. For that, you just need to pass the time as input variable. For example, let's create the horizontal movement of this square. For more comfortable work with one dimension, I will separate dimensions. For that, right-click on a property, separate dimensions. And open the expression field for x position property. And here type linear, open parentheses. Well, we want to pass the time, type time. I want the movement to begin from the 1 second and be happening about half a second. So the next value will be 1.5 seconds. We need to type the position values which will be changing in time. For example, from current position to 500. Cool, now watch the result. The square is moving and there are no keyframes. By the way, function name reminds the type of keyframes, and this is for a reason. There are is in, is out functions as well, which will allow you to create the animation with easings. All the parameters inside parentheses are the same as in linear, so to make the square move with easing, for example easy ease, just replace the linear with ease. Now the square moves with easings. And if I switch on the expression speed influence visibility, I will see the parabola on the speed graph. Let's create another very interesting trick with this expression. For example, create this color indicator. In this example, keyframes are only on the fill of big circle. Scale of smaller circles depends on the value of each color channel of this fill. And the text in the center displays their RGB color parameters. Let's draw these 4 circles. Name the smaller RGB and repaint them in appropriate colors. Apply fill effect to the biggest circle. Well, the size of the red small circle must depend on the amount of red color in the larger circle's fill. So open the expression field of scale parameter, create a variable C1, and make it equal red channel parameter from the fill. Remember that color value is stored in array, and we need only a red channel, so type 0 in square brackets. Now let's write linear. C1 means our color. And remember that value of each channel is between 0 and 1. And the scale is going to be changing from 0 to 100. But don't forget that scale has 2 parameters, so you also have to pass the arrays. Well, now we can watch, and it's done. When we change the fill color, the scale of the circle is changing depending from red channel value. Do the same thing for green and blue channels. Let's animate the color of fill. Now I want to display the color parameters above large circle. For that, create text layer. And open expression field of source text property. Create 3 variables for each color channel. In R variable, we are going to pick with the red channel, in G and B green and blue accordingly. And let's output the values. Write R plus space separator plus G plus space separator and plus B. We will get really long text line and a lot of symbols after comma in numbers. The color channel values are in between 0 and 1, but in standard RGB scheme they are between 0 and 255. So let's multiply each value by 255. And then round the numbers with math round function. Watch the result. Let's check if the text displays the right color. Yes, RGB parameters are the same. Now your task is to create shadows, and make those shadows be smaller depending on the object's scale, and parent the shadow color of large circle to its fill. Now let's have a look at another cool example. I hope that every one of you remember the homework with paintball, where elements of the game were automatically highlighted when the ball intersected them. Let's learn how to change the value of property in dependency from distance between two layers, where squares are scaling up when the pointer comes closer. First of all, we need to find the distance between the anchor points of these two layers. For that, we have to find the vector length which connects these 2 points. The square will be changing its scale property, so open expression field of this property. Create two variables for position values storage. P1 will be holding the pointer position, and P2 the position of current layer. To find the length of vector, first of all we need to find its coordinates. For that, special function exists. It is called sub, which means vector subtraction. You can easily find it in vector math section of After Effects expression library. So type sub and in brackets P2, P1, so that we found coordinates of vector which connects these two layers. Now let's find the length of this vector. For that, After Effects also has a function and it is called, pretty obvious, length. Create a variable L, type length, and pass to this function our vector subtraction result. So the length of this vector is distance. Now let's create the dependency. Type linear, when L means our distance is changing between 50 and 100, the value is changing too, from values, for example, 150 to 100. So that the less the distance, the larger the scale. The greater the distance, the less the scale. Well, let me explain the logic that stands behind this animation. With the help of two values, we control two areas. The larger area determines the moment when the square starts scaling, and the smaller, the moment it stops. When the pointer is passing between these two radiuses, the scale animation is happening. You can parent these two parameters to sliders, and so that you can control size of the area intersecting which pointer will cause animation. And to make the animation smoother, we can replace the linear with ease function. And one more thing. Of course, expression is a very large theme, and that's pretty hard to learn it all in 2 lessons. So we have prepared for you 2 written expressions, which will probably come in handy in your working process. A lot of you asked about how to loop random changes like wiggle. There is no standard wiggle expression for that, but this one, which is written by Dan Eberts. So the expression has the following look. And let's learn how to set it up for our needs. Expression has 3 main parameters: wiggle frequency, amplitude, and loop time. Let's apply this expression to this circle. Now it is not looped because loop time is not the same with comb duration. Just change it to 2 seconds. And now everything works fine. And one more useful expression, which we highly recommend you to use, is animation with markers. For example, we have such blinking done with keyframes. Usually characters blink a lot, and that's pretty routine work based in these small movements with keyframes, especially when you have a lot of layers and keyframes in composition. It's much easier to use markers. Paste the following expression to the property with keyframes, and the After Effects will tell us about the error. Because for correct work of expression you need to create markers on a layer. The hotkey for creation marker is asterisk. And now animation plays in the moment of time where markers are placed. This expression can be used not only for such simple moves as blinking, but for example hands or legs animation if your character is dancing or playing a musical instrument.